toes, we don't have no toes.
Okay, all right, we got a tall order. I'm gonna go through this insanely fast, try to keep up with me. We have a couple things to do before we get to homework. Homework you're gonna get today will be due on Friday. You're gonna have 4 problems, you'll have plenty of room. Each problem that I'll provide you, I provide you a worksheet today. You'll have a half a page of paper to actually work, so you'll have plenty of space, I think. It requires that you have to do differential quotients. Requires you have to do a little bit of graphing, kind of like what we did the last unit, but a lot easier problems than just the normal ones. And then we have the one extra step we have to do today, which we have not seen yet. We covered it a little, I think I threw out the idea in pre-calc, but we never actually like calculated it. So that's what we're doing today. Questions?
Yes. Oh, Warren, did you have a question?
No.
Oh, I know. Is the homework due this Friday going on Discord or second?
Next.
Okay, and then are you gonna have our grades updated before Friday? Also, I'm not retaking tests. I make practice on homework. I thought that could bump it up.
What did you do? I think the only thing I have to enter is practice guide. That's all I have to enter.
I guess I'll go tomorrow.
Okay, well, I was just letting you know, so you're not like, you need to retake your test.
Hey, Ward. What are you gonna those 3 things in for?
And I realized I had 3 things still out there for you.
You had something going on.
Thought I already had things in.
I still have 3 zeros I turned in.
And I realized I'll have to look back and forth there. Didn't realize maybe you're just turning them in. They might be mixed with practice guides. Okay, all right. We have a lot to cover. You're going to want to take notes. I'm going to go through this is kind of pretty quickly, so you're going to want to do the best you can here. I'm going to start with kind of what I consider an easier problem and kind of work our way through a more challenging problem. So 2x squared plus 5x plus 2. Let's start with this problem. We're going to work our way to the end. All right, so here's the idea. You have to, number one, you have to graph these things. Okay, so you're gonna have to review your little like 7-step method for graphing. Where the tails go, where the x-intercepts are, the y-intercept. They are not fractions. So these are gonna be really straightforward and really simple. You don't have to worry about any asymptotes because I don't have fractions, no horizontals. Pretty straightforward. Now, here's how we do it. The tails, where are the tails going in this problem? Going up. Okay, can we stop talking over there? It's getting really annoying. I haven't started today. So, all right, so tails go up. The reason why the tails go up, it's an even power and it's got a positive number out front, so they're going up. If this was an odd power, they go opposite directions. Now, we have to factor to see where my x-intercepts are. When I factor this thing apart, it's going to be plus plus, it's a trinomial rule. You have to break up the 2x squared in the front, so I'm going to go 2x and 1x. Break up the 2 in the back, I'm going to go like 1 and 2. And that will hopefully give me the 5 in the middle, and I think it does. This is 2x squared, 4x, 1x, it does make 5 in the middle if you FOIL it out, so there you go. And now we have to figure out the x-intercepts from this. Question?
This is not what we were doing, Ward.
Yeah, we're doing differential quotients today. I said today was the big stuff, where we're mixing like 9 different things together.
Yikes.
Yeah.
I'm gonna poop my pants. I was like, this isn't what we did yesterday.
Yeah. Yesterday's stuff is the tail end of what we're doing today.
Oh, so do we put this into the differential quotients?
I felt confident for once.
So,
I hate that.
all right. So,
Why would you need to do that?
okay, for this thing, we have to solve this. So this is 1/2, and this is -2. Those are my x-intercepts. So, -1/2, -2. Okay, so those are my x-intercepts. My y-intercept, if I plug in zeros to all my x's, if I plug in zeros for all the x's, it'll be 2. So that's my y-intercept, it'll be 2. So again, these were x-intercepts, how you factor, and that's y-intercept was 2. And then we draw it. Okay, and so it looks something like this. The tails had to go up. I had to pass through each x-intercept once. It wasn't bouncing off any of them. All right. Yeah, we did that in the first unit. That was the first section we did graphing. Even in the last unit test, unit 2, we had rationals. So you had like vertical asymptotes and horizontals. Fine and dandy. The stuff we did yesterday, it was called the differential quotient. It was finding slope. It also has a major use for figuring out where the peaks and valleys are on this graph. And that is what we're actually using it for. So that's what I want to talk about. That's what I want to do on this problem. But is there any questions with the process of graphing?
No.
Now, if you cannot figure out x-intercepts, let's say the problem that I provide you, you can't factor it. Let's say like you tried and you're like, yeah, I don't know how to factor that thing apart. Fine. If you can't factor, that's perfectly fine. You don't have to. You're just going to give me a rough sketch where this thing's going. Like the tails go the opposite directions. You probably can figure out the y-intercept, but then you're going to just draw a rough graph, like really kind of rough. And then what we do is we use the differential quotient to figure out where the peaks and valleys are. So there's still things you can do to make the graph a little more accurate. Now, I'm not going to lie. Some of these numbers you're going to have today will be some big numbers. So yeah, like I know these graphs go to 12. You might have to modify the scale a little bit so that you can fit the graph, because maybe the y-intercept hits 20. Okay, so just maybe say that like this is 20. Just mark it as 20 when you're drawing. Okay.
So they can look whack as long as we label
Yeah,
them.
as long as you label it, it's fine. You're just giving me like a rough scale, because we're trying to put little pieces together in each unit so we can put it all together eventually. Well, today is kind of the day where we're pushing a lot of stuff together. So let's do the differential quotient now. That's the stuff we did the last 2 days in here. It is now the process of like where you use this function, f of x plus h minus f of x all over h.
I don't understand where the H.
What this is
Why do we use H
on the bottom.
anywhere?
Okay, all right, good question. So here's where it comes from. Okay, when you find slope, right? Slope is written like this, correct? Okay, that's slope. What they did is they, instead of writing y's, they wrote it like this. They wrote f of f, you know, that thing they subtract. Because f of whatever variable you use, x, you know, whatever it is, that represents your y numbers, right? This would represent y, that would represent y, that's what it stands for. Those are just names of functions.
So F of X equals Y.
Yeah, it's a y, right? And what they chose to do, they use x in the back, right? But then in the front, instead of using the same variable, they just picked a different letter, a different number. So their variable that they chose in the front was x plus h. The h, like you're asking, like what does the h mean? It is just a slightly bit off. It's slightly off from the original x they chose. Because what they're doing here is they're picking an x, and they're picking an x that's insanely close to it, that's off by just h, a very small gap. And when they pick two that are so close together, you'll eventually find the slope at that exact moment. Because it'll be the actual slope. Because if I pick two slopes that are really far apart, right? If I pick this dot, maybe this dot that I chose was right here, and I picked the dot really far away, do you agree that was a very different slope?
Yes.
But if I pick dots that are really close together, the slope is a little more accurate, right? Compared to where I need to be. So what they're doing is they're choosing h as this weird number, so it makes the gap insanely close together. And eventually, what we're going to do today is learn what we do with h.
So can those lines curve at all, or are they always straight?
What, slope lines?
The black lines, yeah.
The black lines can be curves. They can be all over the place. But what we're looking for is when slope is a straight line and we're looking at a very specific spot. And that's what we're doing today. We're putting this all together to fit it
So
all.
we're finding the bottom.
Yes. Okay, now, to answer your question, where the h came from, they did this, right? They picked an h that was really close. They subtract. Well, if I just subtract the bottom, what happens to the x's on the bottom? They cancel, and you're left with that.
Boom.
It's the same thing. So now, I know it's a very weird way to write it. Now, let's talk about what we're going to use this for, because this is the things we did yesterday. That was it. We just practiced this twice. That was it. We called it a day. That's great. It's easy. So, you take the function, you plug in the x plus h into it, x plus h, plus x plus h, plus 2, and then we subtract the original function, which my original function is 2x squared plus 5x plus 2, right? And then this is all over h, right? That's what we did yesterday. That was all the stuff, you know, so now this is all starting to come together now. Okay, we're gonna do the same thing. I'm gonna finish this problem out because I give you plenty of room. You can do the differential quotient all over that page. So we do this math. So we have, this ends up being, if I FOIL this out, there's two parentheses here, this ends up being x squared plus xh plus xh plus h squared. Eventually I'll distribute the 2 over it. Distribute the 5 over this part, 5x and 5h, and the 2. In the back, I'm going to distribute the negative sign. So that's negative 2x squared minus 5x minus 2. And we have the h in the back. Hopefully you're kind of seeing what I'm doing. This is all the stuff we did yesterday, so it shouldn't be radically new now. Okay, we distribute, and here's where I'm at so far.
2x squared.
2x squared, 2xh, 2xh, 2h squared, plus 5x plus 5h, plus 2 minus 5x squared.
What?
Oh wait, minus 2x squared, I'm sorry.
Minus 5x minus 2.
Minus 2, okay. All right, we distribute everything in, we get to this point, this is all over h. Now it seems weird to write it like that. Things cancel out if they don't have h's, and it should work out if you see it. The 2x squares are gone, the 2's are gone, the 5x's are gone. Everything that doesn't have h's should cancel. That's how you know if you're doing it right. And we get down to this point where, yeah, I have a couple xh's, and I know a lot of you just kind of added it and said it was 4xh's. We have the 2h squared, we have the 5h, and we divide everything by h, and then you start to simplify, right? And this is the part that we ended at yesterday. We divided everything by h because that was a law of division. We got to this. And yes, a lot of the questions I had yesterday, can I just, combine like terms? Like combine the x's, yes, you can do that, make 4x's, cool. That was the differential quotient. Do you agree that's what we did yesterday?
Yes.
We have to go the extra mile now. Well, the extra step that we have to do is now the question you asked.
Wait a second. So 2x plus 2x, and you started with 2x squared,
Yes.
okay? And then you got a 2h, and you started with a plus 2, and you got a plus 5, and you started with 5x. I feel like you can just do a shortcut and kind of convert it over just from like the boom.
What do you think the next section is going to be?
Why do we have to do all that crap then?
You just have to learn how to do it. Now, this is the real math guy. Now, the shortcuts are just things we've learned from observations. Okay, we'll come back to that.
So
Now, okay, so now, we get to this point. What we need to do is figure out the peaks and valleys on that graph. I can already see where a peak and valley kind of roughly is. We need to figure it out. So what we do is we push h to be 0. So that'll be the next step. We're gonna make h actually equal 0. I want that gap to be so small, I'm right on top of the dot where I'm trying to find my slope. So there is no gap between the two dots I was picking. The gap is literally the same dot. I'm gonna find the slope at that exact moment. And what I'm also gonna do is take whatever this function is that I have here, and I'm gonna set it equal to 0. Now here's why. The thing I got from this differential quotient was the slope. If I make my slope equal 0,
flat.
it's flat, it's a horizontal line. I'm actually looking for this moment right here where my slope is exactly 0. I'm finding the moment when I hit my peak and valley perfectly.
Oh,
That's
so
what
you're
I'm
forcing
doing.
that h to come together at the bottom.
Yeah, basically, I'm forcing that h to come together so it's directly at the bottom, or if it was a peak, it'd be directly at a peak. Because I'm squeezing it to the point where it's right on top of it. And so these are the two things you have to understand that you need to do now. This is the new stuff today. Everything I've done up to this point was section by section, kind of leading us up to this moment. Hint, yeah. So now we're going to solve for where the peak and valley is. So we're going to plug in 0 for h. So this would literally turn out to be 0, right? 2 times 0 is 0. It's gone. And I'm left with this. That's what I'm left with when I plugged h at 0. And I set it equal to 0 because that's what I just told you to do. I'm showing you that I want you to set it equal to 0. Whatever this function is, it's called a reduced function.
Oh, right.
It's my slope. I want it to be equal to 0. Okay? Let's see. Okay.
Ward, speaking of that, you think if I brought that white box in, we could figure something out?
Yes. Now. Okay. Now. At this point, I set it equal to 0. I'm going to solve. If I solve for this thing, I wish I had my graph, so I should have froze it to the board. So I subtract the 5 across, and I divide by 4, this moment right here, that spot is exactly where that peak and valley was sitting. That is my x coordinate for where I was. So if you were looking at the graph that I had earlier, it was something like this. This spot right here, this coordinate was -1 and 1/4. That's 5/4.
Because they're 8
Okay.
zeros, so they're 2 decimals.
And what I need to know is the exact y number where it sits. Question.
Son, you plug that number back into the original equation.
Yes.
Wait, what?
So the number I just found is the x coordinate for where the peak and valley sits. It's 1/4. 1 and 1/4. That's 5 divided by 4. You just put that. You want to put 5 divided by 4. Okay.
So
All
what you
right.
gotta do is cross your final h out, and then you put them together and boom.
And boom, and so, and that x that I got is the coordinate for my peak and valley. What I need to do next, if you didn't hear, is take that number, that 5/4, that -5/4, and you're gonna plug it back in using your calculator into this function. You're gonna take and plug in -5/4, which is the 1 and 1/4 that I just told you, and you're gonna plug it back in to this, and I want to know what the answer is that spits out, because this would spit out my y answer. That's what f of x is. That's what it'll spit out. It'll spit out the y number. And so this is 1 and so it's -1 and 1/4. That's what 5/4 is.
Right?
And you'd square it, take it times 2, take the 5 times -1 and 1/4 plus 2. That's the 5/4. Right. You actually multiply that out. I want to know what that number is. This is where your calculators will become super handy. That dot, that number I'm looking for is the y number that I'm trying to find. Okay, what do you get?
-1.125.
-1.125. Okay, that's it's like 1 and 1/8 or something like that. It's something like that. But I'll just leave it as 1.125.
That's
So that number is the base number that I'm hitting.
Yeah,
So
1 and 8.
-1 and 125. All right, there you go. That's the coordinate for the peak and valley. That's what I want to know today. Not just, what my slope is at any moment. Why do we use the differential quotient? This is why we do it. It's this reason. I want to find exactly where I hit my peak and valley. Now, here's the trick. I'll do another one if you need to see one of these, so you can see how to do it.
No.
Now,
We know
I
how.
need to express what's going to happen, because I hinted at it earlier, or yesterday I should say. I'm going to give you a bigger function than just x squared. So, you will have the differential quotient, you're going to have a cube rule. So you're going to have to cube parentheses together. Multiply, FOIL out
I
3 of
can't
them.
do it.
Okay, so you're going to have to distribute the first 2, FOIL it, then distribute it with the back one. What you'll have in the end, and this is where the only difference will be, I'm not going to do Pascal's triangle today, I'm not doing that.
Big wall.
We're going to look at it later.
Oh, beautiful word.
The only thing that will be different is right here. You're going to still plug h of 0 in. The only thing that will be different is this function that you're left with won't be a simple x.
The x squared.
It'll be x squared, something. So you'll have to FOIL it. It will be factorable. And you'll be able to, it will always be factorable, the ones I picked. And if it isn't, maybe you just can't factor. Maybe you're that person that can't factor. You could do the different, or you could do the quadratic formula.
Oh, God.
And that will always spit out your 2 x's. But it should be able to be factored. So let's say you did all of your differential quotient. So this is a new example, right? You did all of your work, blah, 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 blah. Because this thing was, some cubic function. Whatever that thing was. It looked like this on your graph, right? Looked like that. And you're trying to find your peaks and valleys. You did all of your math, and you got down to your differential quotient. And that thing in the very end that you said equal to 0 looks something like this. Maybe it looked like that. You can factor that thing apart, or do the quadratic formula, if you will, and this thing, 9 and 1, that thing will give you what your 2 x's are. It'll tell you this one is a -9, this one's a +1, and guess what those are?
X. Oh.
It is the peak and valley for both of them. It actually gives
That's
you
just the X.
all of them.
So you have to plug 9 and 1 both.
Yeah, so you have to do 2 problems now. Plug that in, plug that in. Now, if you didn't, maybe you couldn't factor, because I know some people don't like factoring. You can always do this quadratic formula. Okay, all over 2a. You can always do that because this is your A number, that's your B number, this is your C number. And guess what? This thing would still spit out -9 and +1. It could even give you decimals if you didn't want to do it.
So I could have done that in the test.
No, not your previous test. Question?
Are we going to do these on one of
I don't remember
the,
after
as we did in the
factor.
previous section?
No,
Previous unit?
not the fraction one.
Okay.
Oh, God, no.
Oh,
I'm picking polynomials that are somewhat backward.
Well, we have to do that in college, so.
Maybe.
Oh, no.
All right.